Okay, so I'm recording. I'll just kind of restate what I just said. Please, 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 please make sure you practice naming. And it would also be useful, wink, wink, to practice the types of like the chemical reactions we did in chapter 3. And I can review some of that today. So that includes like the reactions of alkenes. So we looked at, adding water, adding hydrogen. I'll look at some of that today. But it honestly, it goes without saying that you need to practice naming for sure. There's a lot of, well, not a lot, but there's a fair amount of naming. Oh, and actually, let me do something as well. Before I get started with the review, let me give you your breakdown of the exam, like how many questions there are. So just give me 1 second here. I'll open that up. Where are you? Oh, is this bad news when you can't find the final exam? Okay, I found it. couldn't find the final on my computer. That could have been bad. Anyways. Okay. All right. So let me share my screen here. All right, new share. Okay, so guys, this is the cover page of your final exam. Well, you'll notice on your real final, I'll have the location and date there. But anyways, this is your cover page, and this is like a breakdown of what the exam is. There's 30 multiple choice, 15 fill in the blank or matching. This wink, 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 the matching, wink, 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 is very much like the question on your assignment 4. Okay, so remember you guys just did assignment 4 with me, and most of you, I think 10 of you have assignment 4 done. In assignment 4, there was a matching question. You might see that again in part B. Cough, cough, wink, wink. And then part C would be short answer. So this part C will include naming or drawing the skeletal diagrams, chemical reactions like we did in chapter 3. So I'll have a little look at this now for you guys for review. But anyways, just remember, this is the breakdown of your exam. This is actually one of the shortest chemistry exams I've ever made. And the same thing happened in the winter semester that I did this. This is not a long exam. So you guys, some of you could be out of there in under an hour. It's really, really straightforward. Okay, so let's go back. Let's look at the review together. Okay, so this is your practice quiz. This, like I said, is literally the final exam that I gave in the winter semester. Okay, and you'll notice there's not a whole lot of questions here because we did move this online. So let's look at some of these. Oh, actually, this is good. This is good. Oh, by the way, this is randomized. So if you guys do this quiz a few times, the questions you'll notice will be randomized a little bit. So anyways, so let's look at these questions. These are honestly very, very good reviews, or this is a very good review. Multiple choice. So question number 1, this is a good question, honestly, very pretty easy question. What do you guys think? Which of these molecules here is a saturated hydrocarbon? Which of these molecules? I'll obviously go over what saturated means in a minute.
I think benzene.
Okay, benzene, and any other answers? You're close.
Butane.
Yeah, butane, exactly. So the answer to this one is butane. So why? Why is this butane? Well, a saturated hydrocarbon means it is full of hydrogens. The word saturated means like completely full. So saturated means that it's full of hydrogens, which basically means it's an alkane. Unsaturated hydrocarbons. So imagine you guys did this this practice exam and you did it another time. Remember, the questions are randomized, so you'll see different questions every time you practice this. Unsaturated hydrocarbons would be alkenes, alkynes, and aromatics. So benzene is an aromatic, butene is an alkene, butine is an alkyne, butane is an alkane. So butane is saturated, which means full of hydrogens. Okay, cool. This is also a multiple choice you would definitely see on your final, the rough difference of hydrocarbon boiling points. So the easy answer to number 2 is the larger number of, the larger amount of carbons, the larger number of carbons means it's going to have a larger boiling point. And that includes things like branches. If you have branch chains, it would increase the boiling point. But here, we're not looking at branches, we're just looking at boiling points for 6 carbons, 7 carbons, 8 carbons, and 9 carbons. Oh, sorry, pentane is 5 carbons. And then octane is 8. Sorry, I thought they were going in order, 6, 7, 8, 9, but no. 6, 7, 5, 8. That's just the computer randomizes them, so that's why it's not in order. I mean, really the only options here, if I was a student and I was answering this question, and I'd say somebody in the chat has already answered it, I'll have a look in a minute. But if I was doing this question on a final, I mean, I would immediately eliminate the ones in the middle. The highest boiling point, like logically, if this was a question you've never seen before, it would probably be the smallest or the biggest. It wouldn't be one in the middle. And we know that the more carbons, the higher the boiling point. So octane is my winner. Let me just see the chat. Yep, so Naim in the chat nailed it. Now, I have a question for you guys. What would have a higher boiling point, octane or cyclooctane? So it's the same number of carbons, but one is a ring. What would have the highest boiling point, octane or cyclooctane?
Cyclooctane.
Yep. Everybody, right? Saif, Naim, Ali, whoever was in the chat. I didn't see your name pop up, I'm sorry. Or whoever was online, sorry, or used voice. Yeah, cyclo. Cyclo groups typically have a 20, and you do not need to memorize this, but typically 20 degrees higher than their analogous hydrocarbons. So meaning it's not really fair for me to compare cyclopentane and butane. They don't have the same number of carbons, or cyclopentane and hexane. That's a very difficult question to answer. But if I said cyclopentane and pentane, obviously cyclo wins. All right, next question. Oh yeah, a lot of these questions, guys, you will see they would be the same. Definitely the same. Now, this is a good one. This is new. This is question 3 on this practice exam. This is actually new. We just did this on Monday's class, or maybe Thursday last week. I can't remember if we talked. I think this was Monday before your lab. And this is about the boiling points. Yeah, the reason that there's only 20 is I've changed it a little bit from last semester. There's probably about 40 questions, but the way that this works is I randomize it. So every time you do this exam, you should get a different set of questions. So this is, I kept it as 20 so that the practice wasn't too long. But if you did this a second or third time, you would see some different questions. I honestly, besides this, I would make sure you guys had a look at your worksheets with the answers. They're online. They've been online for months. You do not need to look at your labs. Do not study your labs. There's nothing from the labs that isn't in your course notes. So don't waste your time looking at labs. I would do this practice exam. I would also look at your assignments or your worksheets, okay? That would be like, if I had only one night to study, I would do this practice exam maybe once or twice. I would also do the worksheets, and then maybe if I had time, I would look at my assignments, the other assignments. You can check those out. Okay, so this question we did on Monday. And guys, whatever I did on Monday, that is the end of this course. So anything from chapter 6 after ethers, do not study. So the final exam will be every unit up until 6.3, which was the ether. Nothing after 6.3 is on the exam. So yeah, you will need to know 6.1, which was halogens, 6.2, which was alcohols, which is wink, 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 very important. And then we did, you can check this out on my Monday's class. We did 6.3, which was like 4 slides. Anything after 6.3, do not touch. Don't look at it, don't study it. Yeah, sorry guys, this is a review for another course, Chemistry 1120. The question was, is there a way to look at your assignments? You should be able to, but I might have to do something to let you guys look at them. Oh, so I'm in the wrong course. This is Chemistry 1121. Let me pick the right course here. The Zoom screen is like hiding my most of my browser, so I can't really see what page I'm in. Here we go. Quizzes. So what I'll do after this class, I'll go back and double check and make sure you guys can see your like see these quizzes here. I'll have them set up so you guys can study them. Like for example, what I will do, I'll make sure that this happens after class, but if I go to, like I'm in teacher mode, so I can see a lot of things. Yeah, like this one is not set up for you guys to see the exam or see it when you finished it. And that was more so, you know, there would be less copying. Not that you guys would ever copy, I know you wouldn't. But here you go. All I have to do is click this, show the questions, show questions with your answers, show question answers, show score, and go save. And then now when you guys go back and look at this assignment number 1, you'll see the answers that you should have had. All right, I'll do that for everything after this class. I won't do that now, but I'll do it after class. So yeah, you should be able to go back then and look at your assignments. Okay, you could go back and look at your online labs too. I mean, it wouldn't hurt, but I'm not going to ask you any questions from your lab. So don't worry about that. Okay, so back question 3. I'm wasting a lot of time here, I think, but question 3, which would have the highest? Now, again, you could really like answer this, eliminate 2 of these. What do I mean? Well, we know that larger carbon chains are going to have the highest boiling point. So we have ethane and we have ethanol. They're not going to be up there with pentane and pentanol. So really, this is instead of a 4-point question like for A, B, C, D, this is only 2. It can't be ethanol. It can't be ethane. They're smaller. It has to be pentane or pentanol. What we learned on Monday, and Niam just said the answer perfectly. On Monday, we learned that pentanol would be the answer. Why? Because it's an alcohol, or more specifically, it has hydrogen bonding. You don't need to know what hydrogen bonding is, but you did study that in Chemistry 1120 many, many, many years ago or months ago. You did 1120. Don't worry. I'm not going to ask you about hydrogen bonding or London dispersion or anything like that. But alcohols will always have a slightly higher boiling point than their analogous, meaning the same number of carbons, alkane. So if I had hexane or hexanol, hexanol wins. If I had butane or butanol, butanol wins. Even ethane and ethanol, ethanol would have a higher boiling point. But in this case, the answer would be pentane or pentanol. And you just have to think, who wins, the alkane or the alcohol? And the alcohol wins. The reason, like I said, is because of hydrogen bonding. One thing I'll mention too, like hydrogen bonding is actually a very important topic for you guys. If you ever go into a university program, like the college will eventually offer degrees, maybe you want to go study somewhere else. This concept of hydrogen bonding is so important for hydrocarbons. You might be thinking, like, but pentane has hydrogen. Why doesn't pentane have hydrogen bonding? Well, hydrogen bonding is when hydrogen is bonded to FO or N. So you don't have to know that, but just, for the future, if any of you guys plan to do more chemistry, hydrogen bonding is so important. There's an old joke I have with my environmental class. Sometimes I teach environmental chemistry 2770, and I tell the students, if you don't know an answer, just say that it's hydrogen bonding, right? Like, why does water do this? Why does water do that? And if you don't know, just pick hydrogen bonding. Anyways, that's not for you guys. Okay, question 4. Ooh, this is a tough one. It requires you to, and like this question, guys, because it was online, I made this exam a little harder than normal because they could use their notes. Like I had no way to stop them from using their notes. So this is an interesting one. Okay, so this question here, surfactants. There are 4 types of surfactants in that we learned about. We have anionic, cationic, non-ionic, and amphoteric. So anionic are typically ones that contain anions. Non-ionic are typically ones that contain no ions, no cations, no ions, no nothing. Cationic contain cations. And of course, the last one, amphoteric, they kind of contain both cations and anions. This was in chapter 5. Now, when you guys see this question, wink, 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 it will be worded a little easier. I made this a little hard for my students because they could use their notes. All right, so what do you guys think when you're looking? Does anyone have a guess for this one? This is worded way harder. On your final exam, it's worded really easy. And I'm very impressed. Yeah, amphoteric. That's perfect. Amphoteric. Let me just open up my notes here. I'll show you. You definitely want to know this for your final exam. There you go. Okay, the 4 types of surfactants. This was on slide 109. I know that sounds a bit crazy, but I would word it a little bit easier for you guys because you can't use your notes. So for you guys, anionic surfactants, these contain negatively charged ions. Okay, non-ionic, no ions, has no ionization when dissolved. So again, I word this a little bit easier for you guys. Your exam is definitely easier, but you can't use your notes. So that's the difference. But the answer to that one was non-ionic because non-ionic, oops, my boss just emailed me, is highly stable and has limited reaction with ionic things. Okay, because it doesn't react with ionic things, it's typically non-ionic. What else? Let's look at the other 2. Again, there will be a multiple choice about one of these. Anionic, sorry, this was a typo. This is obviously cationic. I don't think this typo is in your notes. This is an old set of notes that I opened up. Cationic obviously contains positively charged ions. These are the ones that really mess with bacteria and viruses, which is pretty cool because in COVID times, obviously cationic surfactants are really good to be used in soaps. And amphoteric, these have properties of both anionic and cationic. These would be kind of like the definitions you would see on your final. So anionic is the one that has negatively charged. Cationic, positively charged. Amphoteric, both positive and negative. And then non-ionic, it would have no charges. That's how it would be worded for you. All right, let's look at some more. I might skip a little bit ahead now. I'm cover some different ones. Clear. Whoops. This question is from section 6.1, so this would be on your final. Typically, the compounds that have halogens would be higher. So halogens increase boiling point. So the answer here, this is a really cool one. Actually, I love this question. Would it be bromopentane, pentane, cyclopentane, or 1-bromocyclopentane? And really what you want to think about here is which is the biggest molecule. Bromocyclopentane would be our biggest. It's the cyclo, which is higher. It has a bromo, which the other 2 do not have. The answer here
Sir,
would be, yes?
We can't see the question.
Oh, sorry. Here you go. At the minute I heard you say "sir," I was like, I definitely didn't. I'm not sharing my screen. Sorry. Okay. So this one, right? Pentane would be the lowest. Cyclopentane would be a little bit higher. And 1-bromopentane and cyclopentane, I don't personally, I wouldn't really know which would have the highest because they're both bigger than pentane. However, I know that if you combine all of this together, so we have bromo, we have cyclo, we have the pentane itself, that would be my biggest molecule and would have the biggest boiling point. This was in section 6.1. I'm not sure how many people were here that day. I don't think I had a lot of people. This was, we did this Thursday last week. All right, moving on. Question number 6. Let's see here. Which is the process where a small carbon chain is transferred from one molecule to another? Basically alkylation. We look first, hydration isn't really one of these industrial processes we looked at. Cracking is when you take a large carbon chain and break it, literally crack it into something smaller. Hydration is when you add water, so typically you would be oxidizing this, adding an OH functional group. This wasn't even in chapter 5, so hydration isn't even a good answer. Isomerization is when a molecule rearranges itself to form an isomer. Alkylation is the reaction where a small carbon chain is transferred from one molecule to another. A small alkyl chain is transferred. Okay, this is in unit 5. Do I have my pen picked? Yeah. Okay, ooh, I like this one. What do you guys think about this one? We did this as well in chapter 5. Which type of substance would be attracted to water? Now, there are arguably 2 answers here, but there's only one perfect answer. Like there's one answer that literally means that it's attracted to water. So what do you guys think? Lyophobic, hydrophilic, hydrophobic, or lyophilic? I don't know if I'm saying that right. It might be leophilic or lyo, but anyways, you get the idea. And I have 2 students giving me their answers, 3 students, Naim, Ellie, and then I just have someone's student number there, 60062379. You're all correct. Hydrophilic. Philic. Now, remember, hydro means water. Phobic means not attracted to water. Philic means attracted to water. Okay, so what the heck are lyophobic and lyophilic then? Lyo just means, well, I don't know what it means in Latin, but like hydro means water, lyo is anything else. So when you have something that's lyophobic, these are 2 substances not attracted to each other. Lyophilic, 2 substances that are attracted to each other. Hydrophobic and hydrophilic is specifically about water. All right, naming. Now, how much of this do I want to do? I mean, you guys are really darn good at naming, I gotta say. You guys have really shown me that you're good at naming. I don't think I'm going to practice too much naming here. I'll probably get into questions 16, 17, and we'll kind of finish this off. However, is there a problem with my, oh no. I'm gonna have to fix that. My images didn't get imported, so I'll fix that after. But for naming, let's just look at question 9, guys, for naming. Question 9. The reason I'm picking question 9 is because a lot of you guys weren't there when I did chapter 4. This is an aromatic, and aromatics are a little different, but I have good news for anybody who wasn't here for chapter 4. The good news is I don't want you to memorize very much. I'm going to give you something in chapter 4, if I can find it. Just give me 1 second to open this up. I really hope I can find it. Benzene derivatives. Yes, here it is. Okay. So guys, when you do your final exam Monday next week, you will be given this. You will also be given that sheet that has functional groups on it, but you will also be given this, okay? So what I would have to do to answer number 9, well, here, let me try something tricky here. I'll see if I can be sneaky with this. Hold on, guys. I'll share my new screen in a second. There we go. So can you guys see both of my screens here? You should be able to. I want you guys to name this molecule on the right. Now, what I do is I go on this, in that sheet I gave you, this benzene derivative sheet, and I find the chemical that matches it. Okay, so this right here matches this right here. This would be benzoic acid. Okay, so you're almost done. What we assume then is that the benzoic acid is on the 1, then I would say 2, and I would say 3. So this would be 3-chloro benzoic acid. The benzoic acid would just be like the chloro and the benzoic acid. You don't put hyphens or anything in there. So this would be 3-chloro benzoic acid. That's really it for naming aromatics. You find the aromatic in this sheet here. The sheet will be given to you on your final. I've already printed them off. They're ready to go. So you find the chemical you're dealing with. This is benzoic acid. I use the name in the bold. I don't use the other name. And then that's it. I would name it. All right, let's look at a couple more, and then I'll stop and see if you guys have any more questions. So let me share my screen. All right, so the rest are just naming. It's all pretty straightforward. You guys are more than welcome to practice naming. Question. Okay, so let's do question 16. Question 17. Well, let's just do the last 4 questions here. Okay, so guys, question 16. Name each alcohol and identify which you would think is the most acidic. This we did in chapter or section 6.2, and we kind of did it in the lab as well. So let's name the alcohols first. 1, 2, 3, 4. So this would be butanol or 1-butanol. B would be 1, 2, 3, 4. So B would be 2-butanol. All right. The next thing you need to know is this alcohol, is it primary, secondary, or tertiary? 1-butanol is primary. 2-butanol is secondary. Now, how did I know that? Well, let's look up here. The alcohol in this group is bonded to one other carbon. Because it's only bonded to one other carbon, it means it's primary. This alcohol, however, is bonded to 2 carbons. So 1, 2. This would mean it's secondary. And to know which is the most acidic, it's really easy. Primary is the most acidic, then secondary, then tertiary. Tertiary being the weakest. So the most acidic is 1-butanol. It's primary. Yep, cool. So Niam, yeah, butanol, 1-butanol, and it's primary, therefore it would be the most acidic. Okay. Now, guys, this question, this is one that has troubled my students since forever. Well, okay, and actually, when you guys see this problem, it will be even a little easier for you, because what I want you guys to do is to draw 2 isomers. Notice that this exam, there's no questions about drawing, right? They can't draw the chemicals. You guys can obviously draw them, because we'll be doing this on pen and paper, or pencil and paper. So I want you guys to draw 2 isomers for this one. Now, what I do whenever I see a question like this is I count the number of carbons total. So 1, 2, 3, 4, 5, 6. This is obviously 3-methylpentane. So, I mean, one of the easiest isomers would just be hexane, right? I got 6 carbons. 1, 2, 3, 4, 5, 6. There we go. Just draw hexane. Another one, why do I have to have the methyl on the third? Why don't I put the methyl on the 2? So this would be 2-methyl pentane. I could have like 2,2-dimethyl butane, right? I mean, you could be very creative here, but keep it simple. I've got 6 carbons, so hexane is definitely an isomer. Or I could just move the methyl group instead of having it on the 3, I would just move it on the 2. Note if you move the methyl group on the 1, it's just hexane. And Niam said them both perfectly, 2-methylpentane or hexane. There's way more isomers here, but I'll just keep it simple. All right, guys, 2 more, and then I'm done with what I want to talk about, or 3 more, I guess. Then if you guys have any questions, you can let me know. I don't have class after this until 3:30, so I have some time. Question 18. Guys, I promise you will see question 18 on your final. It's going to be worth 3 marks. How do soaps and detergents act as surfactants? You do not need to go crazy with this answer. When I did this exam in the winter semester, I was very, very picky because my students were doing this online. They could use their notes. You guys do not have that luxury to use your notes. So keep this answer simple. Okay, there's a few things I'm looking for. Yeah, all right. So how do soaps? This was, yeah, like I said, in lab number 6. And some of you guys in lab number 6 did go crazy and gave me like these giant answers, which is totally fine. But I don't want you to have to memorize anything too crazy. So let's look at this. Soaps, detergents, they're the same thing. Soaps have 2 ends on them. They're large molecules and they have a hydrophobic end and a hydrophilic end. I'm just going to say this out loud. I'm not going to write it down because this is literally in your notes. There's a slide that explains this in your notes. So just kind of listen along with me. So soap or detergents are hydrophobic and hydrophilic. So what that does is it allows the water. Now remember, when you're washing something with soap or detergent, you use water. It allows the water end to be bonded to the soap, and so that would be the polar end, and it allows the non-polar end to bond with the soap. So soaps are surfactants. They have a non-polar and a polar end. They can mix with water and oil to form an emulsion and allow the soap to be washed away. That's really it. You could start talking about micelles. I don't care. I will write that word for you if you don't know what I'm saying. In your notes, it does mention micelles. You don't have to mention that. I want you to mention it has, I will write this down actually. It has polar and non-polar ends. So it helps the water and oil mix. This mixture is an emulsion, and that means you can wash the oil or dirt or the substance away. I'll just say you can wash it away. So how does soaps and detergents act as surfactants? Well, soaps have polar and nonpolar ends. This helps the water and oil mix, forming an emulsion, and then you can wash it away. Cool. All right, 2 more. This is, I know, guys, it's 122. Just give me a minute here. So there's a mistake here. I think when I copied it over from the other course, it missed the answers. But this is actually perfect because you will not have this as a multiple choice. I want you to draw the product of this reaction. So can you guys remember all the way back, good old Markovnikov? Remember Markovnikov's rule? Hydrogen will go where there's more hydrogens. So I have 2 options with this compound, okay? Let me get my pen out. There are 2 options. Remember that the water splits, we basically get HOH. And what happens is it breaks the double bond. And I would get a chemical that looks like this or a chemical that looks like this. I mean, actually, I will get both of them. But my question is, using Markovnikov's rule, which product would you get the most of? Okay. It's actually the difference. It's different than what you would really think. You guys might think, oh, well, the water would go over here because, it has a lot of room, or I shouldn't say the water, sorry, the OH, because it has a lot of room, but that's not how it works. This project or product here is my major. This is the product that I get. How? Why? Like, why does that happen? Well, the hydrogen will go to the compound that has the most hydrogens. So this right here, or sorry, go to the carbon that has the most hydrogens. Remember that your magic number is 4. 1, 2, 3, 4. This carbon has 0 hydrogens. This carbon, however, 1, 2, 3, this carbon has 1 hydrogen. So what happens is when the water molecule mixes or reacts with the alkene, sorry, I'm just going to fix that so it looks like a 0. The hydrogen of the water goes where there are more hydrogens, so it would go here. And the OH, let me erase this, clean it up for you. The OH goes where there are no hydrogens. So the way that this works is the double bond gets broken, the hydrogen goes here, the OH goes here. The hydrogen goes where there's more hydrogens. So that means the OH has to go on the other carbon. Remember, this happens across the double bond. Yeah, thanks, Naim, in the chat there. Whew, okay, I'm tired. One more. Guys, so I just had a review with Chemistry 1120. So this is like 2 hours straight of talking. But anyways, here we go. One more. And then any questions you guys have, let me know. This is a beauty. This is both of these guys, question 19, question 20, 100% on your final exam without a doubt. Even the molecule will look very, very, very similar. Okay, this is kind of my favorite style of molecule to use. It's an easy one to use. Okay, I don't know if you guys remember this, but this is my last one I'll do for you. This is challenging because, well, you need to know what to do, really. This is the one that typically a lot of my students get wrong. So let me show you how this works. When you're adding KMNO4, it's not like adding HBr or HOH or anything like that. This is the one where it gets oxidized. So what happens is what you do, and you can check my notes for this, you can check the worksheets as well, but this molecule gets split. So step number 1, draw it exactly like it looks, but split it. Okay, so split it down the middle. At the end of this double bond, stick an oxygen. All right, let me fix that up. It doesn't look very good. Okay, there you go. You're almost there. If you did this for me on a test, you'd get, like, if this was worth 2 marks, you'd have 1.5 marks. You're almost there. So I split this double bond in half. I keep the double bond, and I put in 2 oxygens on each end. There's one more thing, and again, it has to do with this magic number of 4. Guys, this carbon here has 1, 2, 3, 4 bonds. It's good. It cannot take anything else. This carbon here, though, has 1, 2, 3 bonds. It has room for a little bit more. So what happens is the extra room, the extra bond there, I stick an alcohol there. And that's it. Those are my 2 products of that reaction. Each one is worth 1 mark. If you forgot this alcohol here, you'd lose like half of a mark. You wouldn't get a 0. I don't give zeros, guys. As long as you try, as long as your answer is somewhat reasonable, there are no zeros. I don't believe in that. So yeah, there you go. I mean, that's a very quick but good review. Now, does anybody have any questions? Anything you want me to show you? Anything at all? remember, guys, your exam isn't until Monday. So if you wanna go now and relax, and maybe Friday, Saturday, maybe Sunday night, you wanna have a one-on-one Zoom meeting with me, you guys can just send me an email, and yeah, I'll be there. I can meet with you guys whenever you want between now and Sunday night. Okay. So any questions? Sorry for going a little long.
No, sir. Thank you.
No problem. Thank you very much, guys. Honestly, if you do have questions, email me. Send me an email anytime, any day, any night. You can send me an email 3 in the morning. I don't care.
So I
I
have sent you an email and you haven't replied yet.
oh, I have not. Who are you? What's your name?
My name is Aladdin.
Aladdin. All right. Let me see. I've been a bit busy today, but guys, I'm done classes today. So when did you send me your email?
I think it has been 2 days.
2 days. All right. I'll check that out and I'll get back to you. Is there anything you want to ask me now that I'm here?
No, thank you, sir.
All right, perfect. Like I said, I'm done classes now after 3:30 today, so there's really no reason I won't be able to help you guys with answering my email. Yeah, okay, cool. I did get an email from Razan yesterday, but I think I did answer that today. The question was, can we go over some of the questions you'd see on your final? So, all right. Aladdin, I'm not seeing your email here. Not at all. Anyways, all right. I guess that's it. Thank you, sir. See you in the final, everybody. Thanks for being here. Guys, if I don't write you back in an email, there might be an issue because I'm not seeing emails from, like, for example, Aladdin there. I didn't see your emails. So if for some reason I don't get back to you, like, I don't know, I'll put my number in the chat. If you can't get a hold of me via email, you can contact me at my phone number. I'll give you my phone number here. Just let me open up the chat. So guys, if for some reason I don't get back to you, you can send me a WhatsApp message at my phone number. I just posted it in the chat, 335-30966. Again, I'm not seeing that email from Aladdin. So if I don't get back to you, send me an email. All right, guys, I'm gonna go. Thank you very much. Have a great day. Be safe out there. And if you have any questions, don't hesitate to contact me. Okay, goodbye. I'll see you later.